Okay, let us now go for the IUPAC nomenclature of organic compounds. First of all, what is IUPAC? You know, this actually stands for International Union of Pure and Applied Chemistry. Rules framed by this particular organization are in usage nowadays. Okay. This is International Union of Pure and Applied Chemists. It is a group of chemists which have actually developed some rules for writing the names of organic compounds. Okay. See, in IUPAC, name of an organic compound contains three parts. The first one is a root word or word root. Next. Of course, suffixes written after the root word. Then the prefixes. So these are the three things which we will have in the name of an organic compound. Now, within the suffixes, there are two things. The first one is primary suffix, which is added to root word. Then there is a secondary suffix, which is written after the primary one. Just like the suffixes are of two types, even in the prefixes, we have two varieties. The first one is, of course, primary, which is written well before the root word primary, and this, of course, is secondary. So the overall order will be like secondary prefix followed by primary prefix, then it is a root word, then the primary suffix, and finally the secondary suffix. So this is the order in which the name of an organic compound has to be written. Sometimes one of these or more than one of these may be missing, but this is the order to be followed. Now let us see what all are these. Coming to the first one, let me actually tell you what root word is. Root word or word root. This actually tells us about the number of carbon atoms present in parent chain, or you can say main chain, of course, or the principal chain. Tells us about the number of carbon atoms that are present in the main chain. Let me tell you the different names given when different number of carbon atoms are present. For example, if there is only one carbon, then the root word is a myth. Myth. If there are two carbons, the root word is it. If there are three carbons, the root word is proper. 4 carbons, But 5 carbons, it is a pent. Then coming to 6 carbons, it is hex. 7 carbons, it is hept. 8 carbons, it is oct. Then coming to 9 carbons, it is a non. Then 10 carbons, it is a dec. Similarly, if you got 11 carbons, it is called undec. 12 carbons, dodec. 13 carbons, tridec. 14 carbons, say tetradec. 15 carbons, pentadec. Like that, 16 carbons, hexadec. 17 heptadec. 18 octadec. 19 nonadec. And then 20th. See, 20th, I mean 20 carbons is called IUPAC. IUPAC. Then coming to 21 carbons, it is called hen IUPAC. Hen IUPAC, 22 carbons, it's called a docose. Similarly, 23 is tricose, 24 is tetracose. Like that, it just goes on. And then comes 30. It's called a triacant. 40 is called tetracant. 50, pentacant. 30 carbons, 40 carbons, then 50 carbons. 60 carbons is hexacant. 70 carbons is heptacant. 80 carbons is octacant. 90 carbons is nonacant. And finally, 100 carbons can be called hect or cent. The suffixes. Coming to suffixes, the first one is a primary suffix. A primary suffix is added to root word. I mean, primary suffix is written immediately after the root word to indicate presence of saturation or unsaturation. Okay, to indicate the presence of saturation or unsaturation. What is saturation? If there are single bonds only between carbon atoms, it is called a saturated compound. Only single bonds. In such a case, the primary suffix is a "-ane". See, in general, it is added to root word. Generally, the root word taken is alk. So, this "-ane" is added to alk. Then that becomes alk-ane. So, then that becomes alkane. So, in general, root word is taken as alk. Alk plus ane, because root word plus primary suffix. Coming to the unsaturated compound. See, in unsaturated compounds, I have two varieties. You can have a double bond between carbon atoms, or you can have triple bond between carbon atoms. In case of double bond, the primary suffix is "ene". This is added to alk. Alkene. Alkene. Alk is the root word. Then primary suffix for double bond is "ene". So that overall becomes alkene. Then if you have a triple bond between carbon atoms, you call it ine. Alk plus ine. Alkyne. This is for compounds with unsaturation. Ene and ine. Next. So let us take things like if there is one hydrogen less. I mean from ane, if a hydrogen is subtracted, ane minus a hydrogen is said to be yle. I mean, if it is alkane minus a hydrogen, we call it alkyl. Alkyl. Similarly, if it is ene minus a hydrogen, I mean one hydrogen less than the alkene, then it is said to be alkenyl. Then, if it is one hydrogen less than the ine, I mean alkyne, we call it inyl, nothing but alkynyl. So these are the rules under primary suffix category. Now coming to secondary suffix. This is important. This is interesting. See, a secondary suffix is added to primary suffix to indicate the presence of a functional group. If there is only one functional group, generally that is written at the secondary suffix area. I mean, it is added to primary suffix or written after primary suffix. And if suppose there are more than one functional groups, this is very important. If there are more than one functional groups, then the principal functional group is written at the secondary suffix area. Let me just give you one or two examples. Suppose, let us consider alcohols. Alcohols consist of this particular functional group called OH functional group. And for alcohols, the secondary suffix is ol. Ol. Okay. Then, suppose, in case of aldehydes, where the functional group is C double bond OH, the secondary suffix is al. Similarly, say for ketones, the functional group is simple C double bond O. And for them, the secondary suffix is own. Let me give you some compounds called cyanides, consisting of this particular functional group. See, triple bond N. For these, the secondary suffix is nitrile. Of course, I'll give you the list of all these later, but for now, I think this is enough. But there is an important point to be discussed here. Now, let us check the order. I told you about the root word, then primary suffix. Let us take one of the primary suffixes, that is "ain." And now let us add one of the secondary suffixes. I have taken the first one itself, "ol." So this is how the order is going to be. This is your root word. This is your primary suffix. And this, of course, is your secondary suffix. Now, the interesting point is, when you add a secondary suffix to primary suffix, the terminal E of the primary suffix is removed if the secondary suffix starts with vowel. If the secondary suffix starts with vowel like A, E, I, O, U, then in such a case, terminal E of the primary suffix is removed, and now we have to call it alk plus "ain" plus "ol" is nothing but alkanol. It is not alk, "ain", "ol", it is simply alkanol because E has been removed. This is very important. Now, let me give you one more example where it is not removed. Let's take this. Alk, the root word, plus "ain", I mean the primary suffix, plus a nitrile. Now, again, this is a root word. This is the primary suffix. This is the secondary suffix. When a secondary suffix is added of this type, like nitrile type, which is not a vowel, it is a consonant. Now, when a consonant is being added, the terminal E is never removed. So just keep this E, it is not removed. Then in that case, this will become alkane nitrile. This is how you have to write. Within prefixes, again we have a primary prefix and a secondary prefix. Coming to the primary prefix, a primary prefix, a cyclo, is added. Is written before root word. Is written before a root word to indicate a cyclic compound. In case of ring chain compounds or cyclic compounds, we use this primary suffix only in case of cyclic. It is not used in case of acyclic compounds. Acyclic in the sense having no cyclic structure or ring chain kind of structure. So that is a primary suffix. Then coming to secondary, that is primary prefix. Now coming to the secondary prefix, a secondary prefix is written before primary prefix. Sometimes this may not be there before primary prefix. If primary prefix is missing, then it has to be written before the root word. So written before primary prefix to indicate a substituent. I mean a substituent, or you can say always a substituent, or a functional group but treated as substituent. A functional group but treated as a substituent. This is very interesting. When is a functional group treated as a substituent, and when is a functional group treated as principal functional group? You know, in general, principal functional group. If within the functional groups we have principal functional group written at secondary suffix area, and there is a substituent written at secondary prefix area. You know, among the functional groups, the one with the maximum priority is treated as principal functional group. All others are treated as substituents. The one with maximum priority among all the functional groups present in the given compound is treated as principal functional group, and all others are treated as substituents. So that is very interesting. Let me give you an example. For example, suppose you got alcohol functional group. I mean, there is OH, and aldehyde functional group in the compound. These two are present in the given organic compound. Now remember, aldehyde is given more priority than the alcohol. I'll give you the priority order later, but for now, remember aldehydes are given greater priority over alcohols. So in such a case, this is considered to be the principal functional group. And this, of course, it is also a functional group. But now because there is something who is given more priority is available along with that, we treat this as substituent. It's of course a functional group, but treated as substituent. That is the speciality. It's a functional group, but treated as substituent because aldehydes are there, which have got greater priority than alcohols. And remember, every time you will have different names. You will have different names. See, when aldehydes, see, if suppose there is some other functional group which is having greater priority than aldehyde comes into picture, then of course, I'll give you one more also. Let me tell you. See, there are carboxylic acids having more priority than the aldehydes. Look at this. Now, the problem is aldehydes have got other functional groups having greater priority than them. So now, the carboxylic groups are treated as principal functional group. Carboxylic acid, I mean this particular functional group, This is treated as principal, whereas the aldehyde is treated as substituent. So this is what I want you to understand. You know, every time, for every single functional group, for every single class of organic compound, you will have a minimum of 2 names. Let me give those now. When treated as principal functional group, you know, you'll have a name. And when you treat the same thing as substituent, you will have a different name. For example, consider the same alcohols. You know, when they are treated as principal functional groups, they are called ol. And when they are treated as a substituent, we call them hydroxy. And as I told earlier, principal functional group, if at all it is treated as a principal functional group, it is written at a secondary suffix area. But if it is treated as substituent, it is treated as, it is written at a secondary prefix area. So that is the basic difference. I'll of course give you many examples, but let me first finish up the theory. Alcohols,
Yes,
then there are aldehydes. In case of aldehydes, you know, when they are treated as principal functional groups, we call them al. And when they are treated as substituents, we call them pharmyl or aldo. Pharmyl or aldo. Similarly, if you consider carboxylic acids, in case of carboxylic acids, you know, when treated as principal, we call them oic acid. And when treated as substituent, we call them carboxy. So that's how every single functional group is given a minimum of 2 names. One is when they are treated as principal functional group, and the other one is when they are treated as substituent. The priority order rule. Try to remember this. Now, the one with the maximum priority, the functional group with maximum priority, then name when treated as principal functional group. Now, there is a special category called special secondary suffix. We'll tell you when to use this. Then name when treated as substituent. So these are the 3 special things. Functional group. Let me just start with the topmost, or the one with the maximum priority, that is carboxylic group. This is the one with maximum priority. Name when treated as principal functional group. Just now we discussed. Oic acid. Now coming to the special secondary suffix. We call it carboxylic acid. Special secondary suffix. Then when treated as substituent, you know, we call it carboxy. But this is an interesting one. See, it is the one with maximum priority, but still I have given you The name when it is treated as substituent. I'll tell you when I'm going to use this carboxy. Because it's very clear that it is at the top end. But still I have given you its name when treated as substituent. Let's see when to use this under special case category. So star mark. Now coming to the next one. See, after carboxylic compounds, we have sulfonic group. In this case, name of this particular functional group when treated as principal functional group is sulfonic acid. We don't have anything here. And here we call it sulfo. This is the one that gets second priority. Now coming to the third one. See, these are called acid anhydrides. You will get all different functional groups here. You know, here we call it oic anhydride. Oic anhydride. And when you go for special, you call it carboxylic anhydride. No substituent name for this because it cannot be written there. Now coming to the next one, it is ester. C double bond O. Looking at this, you have to say that it is an ester. Now coming to the name when treated as principal functional group, it's called O8. O8. And special is carboxylate. When treated as substituent, we call it alkoxycarbonyl or carb alkoxy or alkanoyl oxy. I'll give you different examples. Alkoxycarbonyl, mostly used, or carbalkoxy, or alkanoyl oxy. This is when you have esters. See the priority order. First carboxylic, then sulfonic, then anhydrides, then esters. See, after esters, we have acid halides. This is the functional group. And this X can be anything, mostly chlorine, bromine, iodine. It's a halogen. Right? This is acid halide. Now, these are given the name oil halide when they are treated as principal functional. Special, it's carbonyl halide. And coming to the name of the substituent, we call it halocarbonyl. Halocarbonyl. This is for acid halides. The next one, that is amide. So this is called acid amide because these are all the derivatives of carboxylic acid. See, in place of OH, I have written X here. In place of OH of carboxylic acids, I have written NH2 here. So they have become acid derivatives. This is acid halide, and this is acid amide. These are the derivatives of carboxylic acids. Now, in this case, we call it amide. Amide, then carboxamide, and when treated as substituent, we call it carbamoyl. Carbamoyl. Yes. The next one is cyanides. Nitrile, when treated as principal functional group. I already told you this. Nitrile, and here it is carbonitrile. Now it is a cyano. Cyano. When treated as substituent, it has to be cyano. Then let us go for the carbonyl compounds. See, in case of carbonyl compounds, we have aldehyde and of course ketones, which we have used in the previous example. These are aldehydes. In case of aldehydes, you know the name when treated as principal functional group is al, simple. And the special one is carbaldehyde. Then the name when treated as substituent is pharmyl or aldo. I told you this on the other day. Pharmyl or aldo. In fact, it also has another name. We'll put a star over here because this is a special case. You know, sometimes we call it oxo, just like the ketones are called. But let me give you an example of when we call this oxo. Of course, this is actually used for ketones, but even in case of aldehydes also it is used in certain cases, in some special cases. We'll tell you that later when I take examples. But see, it has got 4 different names. 4 different names, not just 3. So after aldehydes, we have ketones. This is the functional group for ketones. Name when treated as principal functional group is one. It's not one. One. No special secondary suffix name. Coming to the name when treated as substituent, just now I told keto or oxo in the previous example. Next. After this, I have alcohols with the functional group OH. Name when treated as principal functional group is ol. For aldehydes, it is al. For alcohols, it is ol. No special. And in this case, it is called hydroxy when treated as substituent. Coming to SH. See, these are called thiols. Thiols. When treated as principal, it's called thiol. And when treated as substituent, it's called mercapto. And then amines. Amine when treated as principal. Amino when treated as substituent. After this, of course, we get a double bond for which it is ene. Then, of course, a triple bond for which it is ine. I've already given examples for double bonded compounds and triple bonded compounds. Now, the last one. You know, the last one, of course, are always a substituents category. Substituents are always a substituents category. I have some examples like halogen compounds, halo, nitro, nitroso, alkoxy, nothing but ethers. Then finally, alkyl groups. See, these are ethers, alkoxy. OR, halo, nitro, nitroso, alkoxy and alkyl. These are always substituents type. They are always written at the secondary prefix area. Okay. So this is all about the priority order rule.